it shouldn't be that too stressful for you. First thing is coming out is old homework that I collected at some point. So grab yours and pass on the rest. Second thing, I might have goofed up a smidge, and you know me, I try and own what I do wrong, which is most things in life. So you did have a quiz on Friday. And then I realized when I was making the key to it today, I was like, oh my gosh, a lot of people didn't get done because I'd gotten a bunch of emails from people saying, hey, I didn't get quite done because it was a delayed start and you're probably having to go forward. So what I plan to do, if it's okay with you, is I would like to run through 6.6 because I would have taught this back on Thursday, I believe. And then I'm going to teach 6.7 today. We'll go over 6.7. Do what? Oh. So, and I'll teach 6.7 today, and then go over 6.7 tomorrow, and then do the review also tomorrow during class. And then on Wednesday, I'm going to hand you back the quizzes. So some of you had already started it. Some of you weren't here. So Wednesday will be, if you missed Friday, is your lucky day. We'll have Wednesday be our makeup day, as well as if you wanted to have your quiz back to make any corrections to make it a better score. Sound like an okay plan? So those of you who missed, does that make a little bit more sense? Those of you who didn't get done, does that make a little bit more sense? Take a little off your plate. Bless you. All right, so let's get out this page. What page is this? 103? Because I'll go ahead and collect this today. So 103, have that out. Let's and I will collect it and give you points for it. Deal? All right, it says according to food labeling laws, a certain fast food cheeseburger has 750 calories with a standard deviation of 100. Oh my goodness. We suspect that the actual calorie content is higher. We planned a random purchase of 36 of these cheeseburgers at locations around the country and have them measured for caloric content. Okay. Caloric content. All right. So first thing we do is why don't we just kind of abbreviate. So problem number 1. So our null hypothesis, we'll say hamburger equals 750. And then our alternative, because we think it's higher, hamburger is greater than 750. Seem okay so far? It's like, wow, Strip, we're really starting to shorten our null and our alternative. I know that's the idea if you want to shorten these. It says calculate the mean and standard error. Okay, so the mean is just given to us, being 750. And then the standard error, we're going to take the standard deviation, which is 100, over the square root of 36. All right, and then that comes out to 16.7. So we'll just, to make it simple, we'll make it go to 17. So that's our standard error. Remember, the standard error goes in place for the standard deviation when we're having a sample come out of that. All okay so far? And then number 3 says, hey, let's make our normal distribution based on this. Woohoo! All right, so 750 is here. If I add 17, so 1767, add 17, 784, add 17, 801. And let's see, subtract 17, so 733. Subtract 17, 1716, and 699. All right. Says, assume that our random sample produces an average calorie count of 747. Okay, so problem number 4. So we're going to say 747 is like right here. Okay, so visually, it doesn't really look like it's that far away from 750. So is this strong evidence in favor of our alternative hypothesis? And so problem number 4, we're going to have to say no, it's very close to 750. So this could have been just by random chance. Okay. Now, it might mean something that we did get 747, but 747 is only 3 away. Okay. So I think in the world of hamburgers, it's probably okay. If you're dealing with like a really weird medical thing, I don't know, maybe you look at that and start raising some flags going, fudge. All right, any questions on that? We go okay? All right. Number 5, using your graphic calculator, find the percentage that is to the left of 747. Well, we don't use our graphic calculator. We use our friend, the Desmos folks. Good to see it. We're on page 103, is that right?
Yes.
Okay. All right. So if we're going to use our Desmos on this, so normal distribution, we're doing the 750 as the mean. We're going to use our standard error, which we said was 17. Hit the little plus. It'll find us our normal curve. And so we want to figure out what the value to the left would be. So we're going to have negative infinity, and we're going to go 747. So you're talking about roughly 43% of the area to the left of that is under the curve. So, and then assume our random sample produces a calorie count of 771. Is this strong evidence in favor to our alternative hypothesis? Okay, so let's think about this. Let's go back to our really bad drawing. So they're saying 771. So 771. So it's definitely beyond 1 standard deviation of the mean. Okay, but it still might be due to random chance that this took place. Where you're looking on these types of things is if you become like 3 standard deviations to the right or 3 standard deviations to the left, that would probably be where you're like, uh-oh, we're not figuring out what they have. But this is a little worse piece of evaluation for number 6, but it's still fairly close to the mean of 750 as far as the grand scheme of statistics goes. So that might have been, you might have just had somebody who had, you just might have had bigger meat patties that day or something. All right, explain. So for number 6, so this is a better, but still close. So again, saying that there could be random chance there. Yeah.
What did you say for number 5 again? What's the p-value?
Number 5, we would have came out with 0.43 or 43%. How you ever want to list it. Yeah.
Number 6, it says strong evidence in favor of alternate hypothesis. Didn't it be no? Because it's more than 750.
Right, but it's still close to the 750. So it's better evidence against our null, as far as directions go, but it's still it's only barely 1 standard deviation above our average.
So what standard deviation value would you say we're going to say the alternate is true?
So basically, we're going to start thinking about like this. If that came out to a 0.05, so yeah, so that's real far to the left, or in this case, maybe 0.95. So it depends upon which direction you're going. Okay, that's just your basis, unless you changed your p-value to your alpha, and you can change it. Then you're changing it a little bit. Okay. So yeah, you're talking about far right and left tiers that you're dealing with, depending upon which direction. In this case, it would be a right tier because we're saying they weigh more. And let's explain what a type 2 error would mean in the context of this problem. Okay, type 2 error. Type 2 error. The errors that we don't do the math to figure out, but so yeah, this says we fail to reject our null even though let's see, even how do I want to say, even though it is false, yeah. So in this case, you could say we find strong evidence that these cheeseburgers average more than 750 when they really do, or something like that. But if you can get to the lingo of fail to reject the null when it's really false. Again, this is where, you guys are in the math classes, there's errors that take place. Boy, I wish I took place in all my other math classes, other than my teacher was always marking me wrong. 6 is better, but still. All right. According to a recent government report, 27% of the U.S. population has no health insurance. Oh, okay. We believe that the percent might be lower, but we want to select a random sample of 1,000 people to see. Okay. Ooh, 1,000 people. That's a good amount of people randomly selected. Okay. All right. Are we good to go to number 8? You set? Did I leave anyone behind? All right, so our null and our alternative. So our null is, we could say insurance is equal to 0.27. And then our alternative, insurance, we think is less than 0.27. Okay? Pretty simple. Keep it simple. Abbreviate. You're all right. Basically, when I'm grading this, I'm looking for the equal sign or the less than sign. That's really what I'm looking for. The words before and the words after, you're wasting lead, people. And let's face it, if climate change is really happening, we better be saving as much lead as possible. That's a little sarcasm. Sorry, Monday morning sarcasm. All right. Problem number 9, they want us to find the mean. Well, the mean's already given to us, which is 27%, or you could say 0.27. Okay? If I want to find the standard error, this is the different one. This is the one that is the probability it is minus probability over the sample. So they're saying in this case it's going to be 0.27, 1 minus 0.27 divided by the 1,000. And if I do this appropriately, this is going to come out to 0.014. So let's just round it to 0.01. So this is our standard error. Okay, that's the standard error that kind of gets goofy. It's not the standard deviation by the square root of the sample. It's the entire square root of the percentages. We good so far? Whew, feeling good. Hope you guys had a nice weekend.
Sure.
Yes.
So one time we use the 2 different formulas is when we are given the standard deviation versus not.
Yes. And then if you're not given the standard deviation, then what you have to do is you have to either, if they gave you the percent, that's great, or you'd have to find the percent. If they said 15 out of 30 people, then you have to say, oh, that's 50%. All right. Number 10, construct our normal curve. Whoop, whoop. Yeah, baby, I'm getting better and better at these. All right, so this is 27%. We said that our standard error, we're going to make it just 1%. Is that okay? So that would be 28%, 29%. Because we did this. Hey, started without you. I'm sorry. If I would have realized you were in here, I would have waited. Standard error, you have to do the percentage. This right here. It is point. Yeah, I rounded it to 0.1 just to. I wasn't here on Friday, so crazy. Ask somebody around you what I already talked about, or watch the video. I messed up basically. I prematurely gave a quiz, and when I was making the key, I was like, I really should give a couple extra days on this stuff, and we'll give it on Wednesday. So you missed nothing. All right. All right. Shh. Back in the what row there. All right. So 26%, 25%, and 24%. All right. So that's basically that. Which result for number 11 would show, let's see, yeah.
Does that say 29% or 24%?
That's a 24. Syrup can't make fours today. All right, so number 11. Which would be worse? Okay, which result would produce stronger evidence of our alternative hypothesis sampling? If we found 22% or 24%. Okay, so 24% is here, 22% is over here. Okay, so remember, we're trying to show our alternative is insurance is less than 27%. So if we want to do this, we would have to say yeah, there we go. So 22% is worse, or this would show further from our mean of 27%. Okay? So what's further away from 27? 24 or 22? That's a tough question. Okay? And then, let's see. I got to put that down a little bit. Explain why random samples shows that 36% of the U.S. population has no health insurance does not provide evidence in this case. Ooh. Explain why a random sample shows that 36% of the U.S. population has no insurance does not provide strong evidence. Okay, so we're trying to justify that we think that less than 27% have health insurance. If we did another study and we found that 36%, well, 36% is way over here. It's almost a free guy poster, isn't it? Okay, so 36% is way over here to the right. Well, 36% would encompass what our whole thing would say. You know, from 27% down. I mean, it's got 36% on down. So in this case, explain why this doesn't give us good evidence, and a good reason for this said, one, the result is in the opposite direction, and it provides evidence that the percent with no health insurance is greater than 27, not less. So if we were on number 12 to say, hey, you know, we showed that we had 36% is way over here. We were trying to look for people less than this. So 36%, being you go from 27 to 36%, I mean, this would be absolute garbage to make conclusions based off this. Okay? And then if we ultimately decide to reject the null hypothesis in our study, explain what that means. Okay. If we decide to reject this, okay, what that means is we found evidence that the percent without health insurance is lower than 27%. So if we reject our null, we're saying, no, we said it's 27%, so we're going to stick with that. And all of a sudden, if we reject that null, that means that less than 27% have health insurance. Okay. Anything else I need to run through on that? 12?
It's above the mean instead of under it.
Yeah, it's way above the mean. It's the wrong direction from where we're even trying to state with our alternative hypothesis.
Just say 2 month old.
Burgers do average 750 when they're really
Did you get 13?
Which one? 13 says, we decide to reject the null. What does that mean? We reject the null means we found evidence that less than 27% of the people have insurance. Homework. Homework. You, and also you. Write it down quickly. I like it. Two. Hey.
So
This is the worst class you guys have ever had. Homework. Any more homework? Roll once, twice. Hey.
Can I give you this and just?
Sure. See this folder that's open right here?
Yeah.
Spencer, I just saw you didn't write your name on yours. I was happy that it was the last one I collected, so I know who it was. Now you're set. All right. Hey, I'm going to be on this 6-7, calculating the p-value of a one-tailed test, which is page 36.
Yeah.
Page 36. Okay. So page 36, we're good to go? So, finding the p-value. Yes, we're finally going to find the p-value. This is where I realized I had made an error because guess what it asked you to find on the quiz? Find the p-value. I'm like, I didn't teach that. When's our quiz completion update time? Wednesday, I say? We can do that. All right. So calculating the p-value on a one-tailed test. Okay, so we're doing a directional test, correct? If it's one tail, less than or greater than. All right. So as recall, we informally defined the p-value as the probability of obtaining a result at least as unlikely as the one we obtained by random chance. Okay. So again, this means that you had some normal distribution that took place, another random sample that taken place, and that random sample, all of a sudden, things weren't the same as you had thought, basically. So, says we begin with the null hypothesis sample and distribution. Locate or sample statistic of the distribution allows us an early look at the likelihood our sample was produced by random chance. As we learned in the previous assignment, the farther our sample statistic is from the null hypothesis mean, the less likely that random chance explains our sample, and there's more evidence against our null. Mint? What? Yeah.
I'm trying to do this all.
Trying to read this. Okay. So the p-value is simply the likelihood of obtaining a statistic at least as far from our null hypothesis as our mean sample. This assumes our sample statistic is correct direction as our alternative hypothesis. Something we'll discuss later. I know you can't wait to discuss it later, but we'll do it. It says, as a practical matter, we can represent the p-value as a shaded region on a normal distribution. Assuming the sample distribution is normal, we can use Desmos to calculate the p-value. You guys have been calculating the p-value all along. We just didn't call it that. Okay? Assume that, then they're going to give us an example. Assume the average price for a new movie ticket is known to be $11 in the year 2010. Oh. average movie ticket was only $11 in 2010. Those were the days. Has the price of a ticket risen since then? Assume our plan is to survey 600 random movie theaters. So our null is basically, they're using just the lower Greek letter mu. Okay, so mu is equal to 11, so ticket price is equal to 11. And then our alternative is ticket prices are bigger than $11. So draw our sampling distribution based on this. I need to get a calculator. I can't do it in my head. Oh, yeah, baby. Who's playing videos in here that I can hear? Okay, it happens. All right. So our null is movie tickets are equal to 11. Our alternative is movie tickets are greater than 11. Okay? So 11 is going to be right here. And then we have to figure out our standard error. Okay? So our standard error is going to be I missed something. You know what I'm missing here? Anybody see what I'm missing here? Did I miss it in the? What are we missing here? Who sees it? Huh? Huh? Yeah, we don't have a percentage or we don't have a standard deviation. All right. So, friends, we have to make up, I'm going to make up a standard deviation. So let's say that they had said movie tickets were 11 with a standard deviation of, I don't know, $2. Is that all right? So we had to make up a standard deviation. So I'm going to write that on here. So add this, friends. All right. So notice I use the same typeset to write that in. All right. So now that we have this, now we can go ahead and figure out our standard error. We didn't have a percent or anything, so I think we were just missing data. So if I was going to find my standard error, it's going to be the $2 over the square root of 600. Okay, so 2 divided by square root 600. So that's 0.08. Okay, so that means this is 11.08, 11.16, 11.24. Are you going the right way? And then this is 10.52, 10.44, and 10.36. All right. All right, so if says let's assume our sample produced an average of $11.45. Well, this is 2010.
How are we getting surveys?
All right, so 1145 is over here, right? Okay, so 1145 is way over there. Agree? All right. Does that make sense? So let's actually figure out this p-value. Okay, so I'm going to go back to Desmos, and we did 11, comma, 0.08. Okay, you ready? So we want to show it's greater than something, right? So I'm going to get rid of that. And so they're saying if we got, let's draw a normal distribution. If we got $11.45. Okay. So you guys want a really big p-value? So we ready? So you can count how many zeros this is. Ready? Our p-value on this is point 0.00000009. Is that a small p-value? Guess what, folks? Movie tickets cost more. That is an extremely small p-value. Okay? So if we found that p-value, if I wanted to show the shade, let me just show you where I'd have to go to find the shaded region. Okay? Ready? So this is 11, 11.1, 11.2, 11.3, 11.45. I'm like over here. So I have the shaded region where my finger is pointing on this screen to the right. We are talking about such an obscurely small p-value. Okay? Hey, first off, is that less than 0.05? You know, I want to take a gander at it. I don't know decimal stirrup. Well, it's 50 cents better than a fraction of a fraction of a fraction of a penny. Uh-huh. No? Okay. What do you guys think? Should we get rid of making pennies and nickels because they cost more to make than they're actually worth?
At least pennies.
I mean, I'm feeling better about myself all day long. All right. So, let's get to this one. So, let's assume that researchers choose to set alpha of 0.05. Oh, that's great because 0.05 is our p-value, our default p-value. Okay? What would our research decision be here, friends? What would our research decision be here? If we're saying, hey, we want 0.05 and we're getting something with 8 zeros in the decimal, rejecting the null all day long. So what we're going to do, yeah.
Would it be cheaper just to melt down all your pennies and sell them as copper itself?
Maybe.
Pretty sure it's illegal.
Okay, so we found our p-value to be this. They said, let's make alpha. So we're rejecting the null. We found strong evidence against our null. So bring more money to the theater. Okay? Your dad says, hey, here's $11 to go to the movie. You get there, and it's like, it's $26. I'm only buying one ticket. Doesn't matter. But I'm 16. No, you're not. All right. So in summary, we calculated the p-value as a percentage of the normal distribution that is farther away from the null hypothesis mean than our sample statistic. Okay, caution. Make sure statistic is in the same direction as the alternative hypothesis. For example, our alternative hypothesis movie ticket was greater than 11. This theory, we were trying to find strong evidence. What if the sample produced an average of 1065? We certainly can't see a sample statistic of 1065 as evidence that a movie ticket price has gone above $11. Agree? So if you had done this, you came up with 1065. We want bigger than 11, so 1065 is less than 11. In this case, the sample contradicts our alternative hypothesis, and we automatically fail to reject the null. In this case, okay, fail to reject means we didn't find evidence against null. Caution number 2, it's bad. to use normal distribution to model data that is not normally distributed. Thank goodness we have something called the central limit theorem as a guide to check for normality. For the means, is the population known to be normal? Is it bigger than, greater than, or equal to 30? For proportions, remember the n times p and n parentheses 1 minus p, is that greater than 10? That's your normality, and that's your stuff for your standard error. Okay, so we're getting closer to being good for your quiz that you'll have on Wednesday, which I gave you on Friday too early. But let's have you go through 6-7. Try that out, see if you can figure that out. We'll go over it tomorrow. We'll also go over the review tomorrow. So that means on Wednesday, you will either have the opportunity to finish your test or even do your test.